Let's talk about rational numbers, irrational numbers, repeating and terminating decimals, real numbers, and natural numbers. And some of these you might be familiar with, or if not, they'll probably come to you pretty quick as we go through the video. And the first thing we'll look at is rational numbers versus irrational numbers. And you're familiar with rational numbers, so think for a second. What comes to mind when you think of a rational number? What is a rational number? So hopefully you thought or had conversations that were close to this. A rational number, any number that can be turned into a simple fraction or a decimal. And when we look at examples of a rational number, we can come up with a lot of them. But I listed a couple: 5, -12, 75 hundredths, 3.5, -1 and 5/10, 520, and we can just go on infinitely. But this is any number that can be turned into a simple fraction or decimal. And we know there are a lot of them. Almost every number we can think of is a rational number. All right. Well, then what is an irrational number? And what would that look like if we had an irrational number? Here's what we have. So irrational numbers, a real number, what's that? We'll talk about it a little bit later on, that cannot be written as a simple fraction. So a real number that cannot be written as a simple fraction. We'll talk about real numbers in just a second. But could we think of any examples of a number that cannot be written as a simple fraction? Well, I included a couple for you. One of them you might be familiar with, pi. We use and used a little bit last year dealing with circles, and we use some more this year. Euler's number, the golden ratio, square roots of some numbers. We'll do some square roots a little later on, and so 2, 3, 99, and others. Essentially, if you cannot get a simple fraction or decimal out of a number, it's an irrational number. If you're trying to turn it into a decimal, and that decimal just continues infinitely without repeating, then you are dealing with an irrational number. So let's talk about, we talked about real numbers right over here. What is a real number? Let's see. So what is a real number? A lot of people wondering. What do we think? A real number, and this is kind of the definition right over here, but this is a value that represents a quantity anywhere along the number line. So we think of a number line, we're going to be talking about more than just rational numbers, and here's how we can tell. I like this example right over here. It says includes all whole numbers, integers, rational numbers, and irrational numbers. So now a real number can be a whole number, it can be an integer, it can be a rational number, and it can be an irrational number. So it's a really large set of numbers that are encompassed with real numbers. Remember, rational numbers, a rational number could be an integer or whole number, but not irrational. Real numbers include irrational numbers too in that set. So then, what's a natural number? That'll come up a little bit. What is a natural number? Any thoughts on a natural number? So a natural number is any positive whole number from 1 to infinity. So not negative, no fractions or decimals, kind of like the counting numbers essentially. But then when I say that, this question comes up. So then how's a natural number different from a whole number? Thoughts? Well, natural numbers do not include 0. 0 is the only whole number that is not a natural number. So a very small difference between natural numbers and whole numbers there, but if 0 is included, then you're looking at whole numbers. Natural numbers only include from 1 through infinity. So if you look at this Venn diagram that I have here, in 6th grade and before, we're kind of used to working in this section right over here, this area. We talked about rational numbers, integers, whole numbers. You knew natural numbers, and maybe you were familiar with them, but if not, you know now. So we were kind of there. Well, what we're adding now is these other parts. Irrational numbers kind of off on their side, on this side by themselves, because they don't really fit with rational numbers. And then the grand one right here, kind of the Milky Way galaxy, the whole thing, real numbers right here. So everything pretty much you can think of is going to be a real number, and this just gives you a real good visual of real numbers. So let's talk about terminating decimals versus repeating decimals. Terminating decimals versus repeating, and these terms right here will probably give you clues into what we're talking about. So if you use this context, this will help you. But terminating decimals. When we have a terminating decimal, this is a decimal that comes to an end. To terminate means to end something. So a decimal that comes to an end, is going to be a terminating decimal. And here's an example. There are tons of them, but if I wanted to turn this right here, 7/8, into a decimal, take 7, divide by 8, and I'm going to get, finally, when I do my division, I ran out of space, but I'm going to get 40 minus 40 right here. I would get 0. My answer would be 875 thousandths. The decimal came to an end. I zeroed out at the bottom. This is a terminating decimal right over here. The opposite is a repeating decimal. So it repeats, it continues. Decimals that repeat a pattern infinitely. Now there's an important word here. Important word is pattern. So a pattern gets repeated infinitely. So some examples, an example, sorry, there are a lot, but 2/9. 2 divided by 9, we just keep going. I wouldn't have enough space because we just get 0.2, 0.2, 0.2, and that's 222 thousandths, but we were just going to continue on and keep getting that remainder at the bottom. So that's a repeating decimal, but notice it has a pattern to it. Okay, the 2 continues. 1/3, the fraction 1/3 is going to get you to 0.33, and if you kept going, you get a pattern that repeats. Those are repeating decimals. So the question then is, well, is a repeating decimal an irrational number? Any thoughts on that? I'll let you ponder that a little bit, but we've gone through rational numbers, irrational numbers, repeating and terminating decimals, real numbers, and then natural numbers. So hopefully you got some good information on this, and make sure you keep this in your notes page for future reference.